Well, hello everyone. What is going on this fine Saturday? Hey Cactus, what's happening? This is gonna be a little bit of a test stream. We're gonna do some actual work, but I'm kind of didn't really plan on doing this. But if you've been following my streams lately, had a little bit of a bad time with my internet connection and like overall stream settings and everything. So I have fiddled and tweaked, and this is actually running on a different internet connection than I typically use for this. The so-called crappy backup connection, and we're gonna see how this works out, because my main connection is for some reason even crappier now, especially with the upstream stuff. So this is probably gonna be a not that long stream. I need to do some other things later on, but we'll see. Maybe I'll go for like an hour and a half or something like that. I'm gonna basically just continue what we've been doing for the past few days. Hey Tamati and Tutu, welcome back. Right, so yesterday I did a little bit of work on the truck bed stuff. And just like I actually said in that stream, the minute I'm gonna stop the stream, I'm gonna figure out what's wrong with my 3D math there. And so I figured it out, and here you can see the wonderful sine wave animated truck bed with just hatches opening and closing, and the whole thing is driven by like a sine wave. I think the bed is like driven by sine wave, and the hatches are driven by cosine wave, so they're a little bit out of sync. And I should add, I added this small script here to one of the test levels. So truck bed work. Let's see. Very simple script. We have a function called start spawning. Creates a timer. Every 2 seconds it spawns a crate, or rather, every 2 seconds it calls this function here, which spawns a crate and then calls itself again with a timer. And that looks something like this. Start spawning. And now we get some boxes, and it seems to be working pretty well. Like the hatches are sort of driving those, or like grabbing those things and bringing them back in if they are about to fall out. All kinds of things. It's pretty cool actually. Boom. Now the thing that the boxes just spawn from a waypoint up there in the sky. So if we drive away, those things are not gonna actually follow along. And if we do something like this, they're gonna start, getting spawned inside of each other, so they're gonna just fly away. Oh, and yeah, you can even get boxes like in between the truck and the bed now, which is also kind of interesting. Burp. See if we can manage to nudge one of those things there. Come on. They just fell off. But I mean, you can just spawn one here from the from this one. Let's put a what did we call it? Dynamic crate 1. That's a big one, and it just like just goes crazy. There are some things, just like with cargo crane, which is also sort of like a similar thing, because it's like an arm that's driven and kind of articulated from the mother vehicle having pieces like this that are just sort of like driven by a very rigid joint, if you get dynamic objects that sort of just get stuck in between this, like the joints don't really care, they're just like they're gonna do their thing, and the dynamic object is typically the one that's gonna be flying away. Did you use any physics library for that? Yes, I use physics 5 for this thing. I do support a number of physics libraries, but physics 5 is what it's used for this particular game. So that's pretty cool. I did, however, not write a whole lot of really nice code yesterday. So there's a fair bit of repeat here. We're gonna probably refactor this into a slightly nicer form. We have the bed itself, which is created here. This is specifically like the physics parts, right? It's actually called create bed physics parts. So we have the bed itself, which is over here. Then we have the left hatch, and then we have the right hatch, and you can see that like they're basically just like copy paste of each other, these sections here. So let's see if we can actually abstract this away. Not abstract, but refactor them into like slightly nicer pieces of code. So if we do like a diff here between the left and the right hatch, we can see that it's basically just like the left and the right words here are the only things that are actually different. So the hatches are essentially the same. The bed and the hatches are a little different because we have that transform hierarchy going, where the hatches are actually sort of attached to the bed itself. And so we have a little bit of different math going here. It's not super different though. Let's see, we have bed physics part. Yeah, so the bed physics part is attached to the parent physics actor. This is the vehicle itself. That's one difference. Then we have the very same thing with like the right hatch part and the bed physics part. They're just like getting replaced everywhere. But then we have something like bed to world matrix and hatch to world matrix. These look a little different. In particular, and I think this was the thing that kind of tripped me up yesterday, is that we are actually we need to do like an additional transform here to actually set the shapes correctly, and this is just something that I was sort of missing yesterday. I cannot get enough of this look and feel. That's a good sign. Thank you. I hope I can keep the excitement going. So essentially what we want here is to create a function, something like create physics part, not parts, but just part, and it will have one of these physics parts here, right? That's the part that we want to create. So part, and let's give it as a pointer. This will be void. But we also want to give it the parent actor, because that's going to be different. So that would be physics actor pointer. And what else? What else do we want? Mass is probably something that we need to give it. So mass, that's an F32. What else? Like all of this joint setup is basically the same. We're just targeting different actors, but all of that, like otherwise, it's exactly the same. Same thing. Do we actually do anything with this graph here other than... Yeah. Okay. Here's a little bit of a something that I kind of need to figure out how to refactor properly. So not only do we have like an additional transform here, as I said, but we also have an additional transform up here. So when we're adding the bed to it, we need like the bed to vehicle local matrix, and then we can use that to create vehicle to bed and bed to world. But with the hatches, we actually do things slightly differently. We have hatch to vehicle, which is like the equivalent of bed to vehicle. So we can call that's something like, you know, part to vehicle matrix in a more generic term. But then this would be like part to parent or something. Hatch to bed, where's that actually used? The search here is a little funky in beyond compare. Let's go here. Hatch to bed. Hatch to bed is actually used here. Yep. Okay, but here we have bed to vehicle. Hatch to bed and bed to vehicle. Isn't that the same thing though? That kind of is the same thing, right? Because the parent is... The parent is kind of the same thing here. But then I also need... What do we need this for then? Okay. Yeah, I think we can actually probably do the same thing. Get local to ancestor transform if we give the graph parent. That is actually the exact same as doing get local to parent transform. At least that's my understanding of this. I said yesterday, was it 2 days ago, that like using this graph is going to make things so much clearer. I'm not sure I really managed to make things clear. But I think this should actually just be the same thing, in which case we can just like, you know, fold all of this into this create physics part function, and then it should... Oh no, I did it too quickly. Alright. Come on, Zig, build your thing. There we go. So does this still work? Kind of looks like it's still working. Yeah. And then when we have that refactored, we can add like a vehicle control, you know, like a role selection here. So just like we can with the mother vehicle, blip, we have this cargo crane role here, which makes it possible to control the arm. I was thinking I would just do the same with the gripper truck. I'm not 100% sure like this role selection menu is gonna be the final way of actually controlling these things, because I feel like some things might actually need to be controlled while or sort of at the same time as you're actually driving the vehicle. This vehicle is gonna get a gripper arm here in the front. That's why it has these sort of weird holes there in the side. That's where it's going to be fastened. So it can sort of take something from here and then sort of throw it into its own bed there. That should be That should be a fun little vehicle to play around with. But okay, for the time being, the role selection menu. So this thing here is what I have to control these things. So let's add that to the truck as well. Okay, let's just get going with this. Let's try to like basically copy that, and we're gonna copy it in here. World matrix. Yeah, maybe we could pass that. We're calculating it here. Parent physics actor. Bed physics material. What's the parent physics actor? Right, it's that one. Okay. Yeah, we can pass the world matrix here as let's do like vehicle world matrix, right? To make it clear whose world matrix it is we're talking about. And the parent actor would then be this thing here. Thing we actually pass in. And then we need to basically rename these like part to vehicle local matrix. Vehicle to part. And part to world matrix. So all the bed words. Almost all of them at least. Part to vehicle local matrix. 32. No, 43. Thank you very much. And we can get rid of that, and we can get rid of the constant there, because we don't need that. Alrighty then. BP props. Yeah. Let's give that as well. We're sort of checking the availability of the blueprint properties there outside, and then we can give them like this. That would be truck bed component properties. All right. So then vehicle to bed, vehicle to part. I could do like just a find and replace here, but I want to do it slightly more manually than that. So material, bed physics material. Yeah, I'm not sure what that should be in the end. I think I'm actually just gonna copy paste this guy and just quite simply get it there. We're just getting the base material here. Yeah, just getting the base material. Do we need to actually release that? Look on the C++ side and see what we have. Does this thing actually like add the reference so that we need to release the reference later on? Might not do it. Get registered material. Nah, it just returns the pointer. So that's fine. That is fine. Okay. Bed mass, that would just be mass. And that's part to world matrix. Which may or may not be different for the hatches. We'll come to that in just a little bit. Just a little bit. Part. Physics joint. Yeah, these are just constants. I'm gonna bring them over as well. I'm going to probably be removing those. So now we have that, but now we are of course still working with the bed stuff everywhere. So this graph nodes, yeah. So that would be we have the physics part, which contains the like physics actor and joint and all of that. But then we need to have like the graph node, which is kind of confusingly called graph nodes because that's like an enum thing. But we can just do it like that, and then we actually reference the correct node there in the graph. in our small transform hierarchy. What then? So collision shapes, bed collision shapes. Ah, this is annoying because it's like this is something that we can't like easily actually. Yeah, the BP props are only used for that one thing. Okay, let's actually refactor this slightly. Let's do it like this instead. We have the collision shapes. You can call them like part collision shapes, and they are a slice of, or constant slice of, truck bed component properties collision shape, something like that. I think that should be perhaps the easiest way to do it. You're not giving it all of the properties, we're just giving it what it actually is interested in. So the collision shapes, and that would be part local, like so. All right. All right. And then we have this bed physics part. Well, that would be just part, right? Just part. This one we can actually just replace like this. Boop, 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 boop. All of that. Okay. Yeah, that should be good. I think that's basically it for at least for the bed version. Bed physics material, yep. So now rather than having to do this, we should be able to create at least a bed using that would be self.create physics part. And for some reason, CLS doesn't want to be my friend today. Is that how it's gonna be? Is that how it's gonna be today, ZLS? Maybe. Self. We don't need to give self separately, but we need to give self dot. Actually, we have something that's probably causing it to barf on the auto completion. Let's see if we have like an error here somewhere. That might be the reason we don't. Huh. Yep, it just does not want to give me anything right there. Self dot, no, not there either. Self dot, here we go. Great physics part. Okay, well, bed physics part, and that's actually the address of the bed physics part we want to give it. Graph node is actually just dot bed. Parent actor. I'm just gonna copy that away. I don't know what it is with ZLS lately, but it's been kind of getting disabled by just having commented code around it. I don't know what's going on. Parent physics actor is like, this would be the vehicle physics actor, right? That's probably a better name for this. Just take that away. Vehicle physics actor is that. Mass would be, you can actually take these and move them here outside of this. So we have the bed mass. Vehicle world matrix. like so. Part collision shapes, that would be bp props dot bed collision shapes dot slice. That thing. And then let's add a comma there to nicely separate those onto different lines. We have bed mass there. Yeah, okay. That's stupid. That should be hatch mass, right? Hatch mass. Or something. This now needs to be world vehicle world matrix. Hatch mass is there. Hatch mass. Hatch mass. Vehicle world matrix. So this should now at least build. Except it doesn't. Unable to resolve comp time value. What? Yeah, that's not supposed to be a comp time thing. That's not supposed to be a comp time thing. And actually, if we search for this, I think I had it in a few other places as well. Yeah, it comes on two joint crane arms, so I copy pasted some of the code from the cargo crane. I don't think I want that as a comp time thing. Much more flexible like this. There we go. Okay. Let's see if that works. And that does seem to work. Let's run the script. Burp. Yep. Looks just like before. Which is of course the idea. Good. Okay. Thank you. Thank you, thank you. And now we have the thing that's going to give us, you know, the benefit of actually doing this thing, but which also might be a little tricky. We'll see. So if I do the left hatch in a similar fashion, get like the hatch mass, take it out of these guys here. We should have a left hatch. Left hatch part, and we should also have a left hatch graph node. The parent actor is no longer vehicle physics actor. This is actually now that would be self dot bed physics part dot actor, because again the hatches are attached to the bed and not to the vehicle. Mass would be hatch mass. Vehicle world matrix is still that, and this would be you know, left hatch collision shapes. And this is probably now just gonna blow up. I'm assuming it's gonna blow up. Yep. And we can see that it's doing something funky. And the funky thing it's doing is, oh, we actually have two of them now. But that would now be the one that we just added, which is just sitting there and not really working. In fact, it's not even moving, which is a little strange. Take that away. Oh, hey! And what is actually probably happening here is that that object is created like, yeah, now you can see now it is actually moving, so that's good. But it is just like in the wrong, it's attached to the wrong thing, and it was probably like colliding with the ground. That's why the vehicle did that sort of weird dance there. Okay, so that would be that. So let's again take a look at this diff here. So we're doing basically this bed to vehicle. That would be part to vehicle local matrix. And we are doing that, right? We're doing with physics part to vehicle local matrix is right here. Yeah, there's a Discord link in the description if you want to join. Indeed. I mean, I can even post in the thing, right? Except I don't quite have the description because we are handy. I can copy it from another place. So there you go. There's a Discord join link. Have at it. If you are interested. Right, where was I? I was looking at this here. So I need to kind of mentally translate this now. This would be like part to vehicle local matrix. That is what we have. That is right there. Part to vehicle local matrix, which is the same as this. No, it's the same as this hatch to bed local matrix. Bed to part to vehicle local matrix is the same as hatch to bed local matrix because the parent matches up with you know the parent for the bed here. But then we also need hatch to vehicle, so part to vehicle local matrix. We need this specifically. Let's get that in here. And let's see. It would go here. Part to vehicle. And this would be part to parent or something like that, right? Part to parent. Let me just copy that. Vehicle to part. So this would be parent to part. Part to parent. And part to parent. And part to world is actually that needs to be done using this part to vehicle because this is the vehicle world matrix. So we need to go from the parts coordinate system to the vehicle, not the parent. The parent might be the vehicle, but it also might not. And then we do the vehicle world matrix, right? That is like that's the first step of this untangling of things, and then this might be something that where we just quite simply want to check if we are doing like a hatch, because this is slightly different. This logic here. We have vehicle to hatch local matrix, which comes from this. Yeah, exactly. I'm gonna move this off to the side just for a second. So the shapes are sort of like they behave a bit differently. Essentially, what we want is the shape transform. The shape transform is gonna look a little different depending on if we are doing a bed or a hatch. So let's do var shape transform, and that's just physics transform dot identity like this. And then we can do something like that. But here we do if graph node is bed, then we do one thing, and if it's not, we do another thing. And And currently we just have the bed and then the hatches. So that's fine. And this would be the way we get to get the transform for the bed. For the hatches, it looks a little different. Let's see. It's actually like this. So position in hatch local. That would be vehicle to part local matrix. Right? Or do we not have that actually? Parent to part local matrix is what we have, but we need specifically vehicle to. Right. So let's add that here. I don't think we need it for anything else, do we? Nah, it doesn't look like we do. So let's do. Yeah, vehicle to part local matrix. Oh, that would be part to vehicle local matrix inverse. And then that needs to be like that. Right? Something like that. And then we have bed to vehicle in the old version. That would be part to parent. I think that should actually now match up. In fact, let's see if it does. I might have missed something, but let's see if this does it. Nope. No, it does not. Okay, let's have one more look here at this. Actually, need to probably put it on the different screen. I'm gonna explain this once I get the math correct. Position hatch local. We're back to the Magic Realm box colliders. We are, yeah. Yeah, I kind of fixed the math already, and now I'm trying to just make it nicer. And it's just as confusing as it was previously. Let's see, graph node is there. Local to parent, yeah. Yeah. So the difference here that we've had before is the fact that like right hatch and bed physics, we have a bunch of those differences here. Then we have one actual difference, hatch to bed and bed to vehicle. Well, the joke here is that those are actually kind of the same, like relatively speaking, from the sort of child coordinate system to the parent coordinate system. Those are actually the same. So bed to vehicle local matrix is this guy, and hatch to bed is this guy, which kind of is the same as that guy. So that difference should be quite okay. And then we have this creating of the joint. Do we do that actually correctly here? Let's see. To create the joint, parent actor comes in here. Yep. Create physics part. And the parent actor is the vehicle physics actor here, but it's the bed physics part actor. So that should be good. So that's one difference. And then the transform is bed to vehicle and hatch to bed, which again should be the same thing, right? Relatively speaking. And so that means part to parent local matrix. Yep. Yes, that looks good. That's all good. So where do we go wrong? Part to vehicle. Part to part is part to parent inverse. That makes sense. And we actually only use that here. So we don't need to actually even keep it around there. That's fine. Then we have part to world, which is here. Part to world is used when we're creating the rigid body. And that would be here. So bed to world, hatch to world. Yep. That looks good. And hatch to world matrix is done by taking hatch to vehicle with the world matrix, or bed to world with the world matrix. That also looks good. Okay, part to vehicle. Oh, here we go. Here's a problem, isn't it? Here's a problem, isn't it? Graph node. There we go. Yeah. That was at least one problem. But was it the only problem? Probably not. You know what? Maybe it was. Look at that. Look at that. Beautiful. I conquered the math once again. Yay. Okay, so now the real reason for why I wanted to do this, we can get rid of that. And we can almost get rid of this. Or maybe we actually can get rid of this. Yeah, I think we can just get rid of this, but let's comment it out for the time being. And then we can do this thing and just do the renaming of left to right here, right? Right. Parent is still the bed for the right one. Hatch mass is good. Vehicle to world matrix is good, and this just needs to be right. What? I screwed up. All right, and I think that the weird sort of jumping that it does there. I think I have a an explanation for that as well, and we might have to look in the physics debugger for that. So I think we're going to do that next. But yeah, this seems to work. This seems to work nicely. It's a bit stupid when I can't control that at all, but we'll tackle that next if this math thing now is actually handled for us. And we can see that we actually don't have these physics objects now on the client. So these are the client physics. You don't see any physics shapes here on the client for the bed or the hatches. Whether or not that is going to be a problem remains to be seen. I also don't have any physics for the cargo crane arm on the mother vehicle on the client. So far that hasn't really been an issue, but yeah, we'll see. We'll see. Okay, so let's use this horrible thing. So the physics visual debugger. And let's run the game. And we can even drop some boxes here onto it. And it should have started recording, and it is recording. You can see the number there going up. Bloops. Alright, that's enough. So, with this guy, alright, we can see that the thing basically looking exactly like we want. Bunks. And we have sort of, you can see it's ever so slight that there's like an overlap. There's like two boxes in one essentially. And that is of course the whoa, what don't give us any epileptic seizures here, thank you very much. Yeah, this tool is simultaneously very, very good and just like absolutely horrible. But the weird nudge that we get in the beginning is, yeah, it's this basically. So if we look very closely at when this thing is created, the movement of the bed is driven by a sine wave. So you can see here, this frame, it is just completely untilted. Can I just step? Is that step forward? Yes. Yeah, that's step forward and step backward. So we can see that in one frame it gets created just completely properly, and then the next frame we are actually applying this sine wave to this bed here, and the bed has moved. The joint hasn't had time to actually keep those hatches connected to it, so it takes like 1, 2. Yeah, now we're basically aligned with the back of the thing. It takes like a frame or two before it actually sort of jumps into place. So that's not really an issue, because of course we're not going to drive this with the sine wave for very long. But you can see them sort of like jumping into place. They even get a little almost like crooked there because the forces are so large. Blip, 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 blip. Yep, alright, that's good. Good. So we can take that away completely, and we can take all of that away. So now we only have the things that are relevant to keep here. We have the vehicle world matrix, which we only want to get once. The vehicle physics actor, which we also only want to get once. And then the masses for those. Alright, that's good. That is good. What do we have here then? We don't need any of that. Take that away. And then the actual like applying of the inputs is still a little messy, but it's not very long, so I might just keep it like this. But apply steering values. So we get these from a propagated value handle, so that this is nicely networked and everything. And we have basically, this is just a vector 2, so we get a tilt amount and a hatch open amount. And bed tilt is set to be a maximum of 32 degrees. And max hatch open degrees maximum is set to 90 degrees. And then we quite simply convert it to radians, calculate the rotation as a quaternion, and we apply it to the graph. Yep, that looks good. And then on the client, we need to actually apply that to the mesh. On the server, we need to apply it to the physics. Yeah, that looks good. Maybe we could just split this out into a function as well, but there's some, I don't know. I think I'll just keep it like that for now. It's probably fine. Doesn't need to change. What does need to change is this steering values stuff. So steering values is the PV, or propagated value, and this is the stuff we want to get rid of. So we have a sine wave and a cosine wave, and that is how we actually drive those things. So rather than having those, we would like to have like a nice roll for that vehicle. So what if we go to like the gripper? Not the gripper truck, but the gripper. I think I had a component here for setting up those rolls. Did I not? I might be misremembering it. Means vehicle type. Yeah, we probably need to create a type for that vehicle as well. How was that roll thing set up? Here we go. Vehicle avatar component. It has a driver and it has a gripper arm, and we need a type for that as well. Okay, that's fine. We can make that happen as well. Blah blah blah. Display name gripper. Vehicle avatar component. I wonder if we have that. I think we have something like that here as well. Yeah, we have. It's called the gripper truck, and it currently just has the driver. That's fine. So vehicle avatar component. No. Vehicle avatar component. This guy, and specifically the blueprint properties. Vehicle avatar role type. Alright, gameplay types. This should now be actually in the library that we, this is in means lib, so this is the library that we split out some of this stuff from a few streams ago. That's good. I'm just gonna close that diff. Don't need that anymore. Rightio. So let's add. First of all, let's add like a gripper truck type to the vehicles. That we can have truck bed here as a role type, and then truck bed. And it might seem a little weird. Why do I have a function for returning that from an enum? You can even have Zig give you the name, but of course we need to localize these later, as the comment there suggests. So that would be why. Rightio. And then we probably also need to add them to the UI definitions in the data. So let's go to basis data, means data, metadata. And then look at vehicle avatar component. I bet it's there, isn't it? I still don't want to upgrade right now, thank you very much. Found actually in types. Vehicle avatar role is right here. Driver, cargo crane, attacker crane, gripper, arm. So that would be truck bed. That's the new one. Truck bed. And yeah, we don't really use the role position yet. That was my idea, that maybe we'll want to have like the camera sort of zooming in on certain parts of the vehicle. That might be kind of cool. Wasn't there actually a vehicle type here as well? Means vehicle type generic. Oh, it's set to generic. Scout, gripper, mother, generic. It's like a means vehicle thing. All right, we can just add a new type here as well. Gripper truck. Like that. Okay, that's good. That's something we don't need. Cool. And then just reload component, UI definitions. And we go back here. And let's see. What do we have? Potentially this is going to be easy, but let's see. See how complicated it turns out to be. So now we should be able to, yeah, now we can do gripper truck as the means vehicle type. And then here we have driver. Let's add another element here, which we set to truck bed. Look at that. So now if we run the game, oh, we haven't built it yet, so it might be confused. Yeah, driver. Okay, let's build the thing. One avatar role changed. Yeah. Okay, we already get sort of thrown into the deep end here, but that's completely fine. Gripper arm controls, cargo crane controls. Well, we will want to have this role here specifically for the controls. So let's just add truck bed controls. 43. I just have these numbers here because like ZLS doesn't give me the numbers in a handy way here through like IntelliSense or anything like that. So I just have them here too. Well, sometimes helps with debugging if you do that. So if we are moving away from truck bed controls, if we're moving to truck bed, we add the truck bed controls. So this should make it so that if we switch to the truck bed role, we can no longer drive the vehicle. But we don't have any truck bed controls yet, so they won't do anything. Right. So if I steer now, you can see the wheels steering there, and if we move to truck bed, now it no longer, like, I can't do anything. Now I can again. So that's what we want. Okay. So let's just make it so that we can actually tilt and open the hatches. Oh, tilt the bed and open and close the hatches. I think that's a pretty good target for this stream. Shouldn't be super tricky to do. What do we have? Yeah, here is where we we'll want to actually map those. Next ID, truck bed controls. And here we do assert inactive, Probably best to add this here as well. I think. And then we had those things. That's good. Okay. So, what do we want to do? What do we want to do? We want to do truck bed, raise, truck bed lower, truck bed open hatches, and truck bed close hatches. How about that? And we need to not only map those things, but we need to actually register them here as well. And input ID truck bed race, and that would probably all be input states, input type state. In fact, I think, yeah, that's already an input type, so this could just be, again, with the new Zig, we can just do that dot state. Input ID with a big D. Truck bed lower, truck bed open hatches, and truck bed close hatches. Right. Just get rid of all of these. Just make it a bit shorter. So, actually, in this case, yeah, this is something that Zig has enabled us to do for a long time, actually. But still, it's nicer that way, I feel. Okay, so now we can map them, and once we have mapped them, we can use them. Simple as that. So. Should maybe do like y, a, x, and b on the gamepad for this. So input ID, raise truck bed, gamepad button dot, set that y, and context is just context. Lower truck bed open hatches, truck bed close hatches. So lower could then be A, open is maybe X, and close is B. So that would be the gamepad. Then we need to do something similar for keyboard input. And this would be key codes. So let's just do like, I don't know, up, key down. I don't have anything anything really thought out, figured out for this. Let's just do like E. I can't use Q because Q is actually used to change the let's just do like C and X for now, just so we have something. I mainly play with gamepad anyway, so I need that to be nice and usable. And keyboard should be nice and usable as well, of course, but I probably need to sit down at some point and really try to figure out what would be the good default keyboard inputs. Right, so let's see if we can build this. And if we can build this, it should be a really simple thing to make the whole thing work. Trackpad component. Is it already in pre-tick where we do that? No, it's in tick. Yeah, I think I've usually done these things in pre-tick. Tick delta time F32 void. Right. How has the stream been, by the way? Since this is sort of like a test stream. Has the stream been more or less solid today? And if you weren't around in the very beginning, I mentioned that I've had some internet connectivity issues and things like that have sort of made life a little difficult for my stream viewers. Haven't necessarily even recognized it myself or realized it myself that the stream is not at the best of health. So this is me basically trying out something with some updated settings, if you will. Alright, so now we can quite simply do if self context get input state, and this would be, we'll probably need to do like const, well, come on, const means import means.sig, and from that we can access all the input stuff. Means.input id truckbed race. Let's make the raising and the lowering work first. Yeah, this should be just as easy as increasing and decreasing that value. It should probably be pretty slow. Let's add a race or tilt speed, probably like tilt speed, bed tilt speed maybe 0.1. I don't know. I have no idea how big that should be. But let's do tilt. Tilt is self steering values. Get. Actually, we need the whole thing. So let's do steering values. Let's do it like this. Bar. So SV steering values, right? And then SV dot x plus equals plus equals bed tilt speed, right? I need to limit it though. Is normal, yeah, that's not what I actually want. But we can do probably std math. Or is it clamp? Nah, no, there's no clamp. So let's do std math clamp, any value, value lower and upper, right. So steering value.x is steering value.x plus bed tilt speed. Lower would be 0 and upper would be 1. Right. Isn't that basically what we want? I think so. Something like this. And then I think we have in basis math vec2 is almost equal. Right, so let's do actually this const prev sv. And we set that to prev sv. So we store copy of it, and then if sv is not almost equal, so there's a little bit of an epsilon there of floating point values. If they differ, then we do self dot steering values dot set with the new value, so we don't spam the network connection unnecessarily, right? Maybe we should even, if we're ticking at a different speed, then we should technically, I guess, use that. Something like that. Let's see. Duplicate struct name. What? Oh, I have it there already, but that's a strange place to have it. Okay. So, up and down, they don't do anything currently, but if we switch to truck bed, they also don't do anything. And no. No. By the way, we should probably check self context is get avatar host ID is not it's not -1 essentially, but I think if it is, then these will just not return anything sensible, so it's probably fine. Let's print something here to make sure that we can actually running this. Printf raising print and basis print lowering. Right. Actually, let's even do this. Print setting. So truck bed, like so. Raising and lowering. Raising, lowering. Oh. What? Raising and lowering. That's not good. Why are we doing both? Raising, lowering. That's not good. That's not good. That is because I'm being bad at my job. That's why. Just bad at my job. Okay, hey, look at that. Lower and raise. I guess that's a somewhat realistic speed for a bed like that, but maybe we'll want to just make it a bit faster to make the game a bit more fun. We'll see. I'm gonna double the speed now, and then while we're at it, let's do a hatch speed as well. We're gonna just keep it at the same for now. Cool, so that's good. And we do the same thing basically with the hatch. So truck bed hatch open hatches and truck bed close hatches. It's essentially just Y, and Y, and then hatch speed. Super basic code. All right, so open and close. Look at that. It's actually working. Yeah, I think this is a more suitable speed for something like this. And now, of course, we can start spawning those things again. Bunk, bunk. I don't have a command to actually stop the spawning though. Pack it in, guys. All right, let's drive away now. Yeah, that works. Let's let one of those out. Just one. Close, close, close. Hey, look at that. And then we probably want to add a similar sort of command to this system where you can just, you know, you can have the vehicle close it and lower it for you, essentially all in one go. So that if you come to a vehicle and it looks like this, actually it looks like, you know, like this. It's fully up, and then something like this, and then you're like, okay, so now I want to drive it again. So then you can hit a key, and it will close it and lower it like this, and you can just start driving away immediately. That's cool. Good to know we can use this vehicle as a catapult. Anything can be used as a catapult, as far as I'm concerned, with this physics simulation. Cool. Okay, this is basically what I wanted to do today. Let's play around with this a little bit in the depot level. The depot level is part of the campaign, and this is a level where we will actually need to use one of these vehicles. And in fact, something that I'm a little nervous about, but we will actually even have the AI driving around one of these things with cargo in the back. So that's going to be interesting to see how it manages. All right, can we drive this now to the depot and unload the thing there? And yeah, currently there's no AI driving in this level. There's no nav mesh or anything, but I guess we could oh boy, let's do this. Let's do this. I guess we could dedicate maybe a stream to making this level AI playable. Right, if we pack those there like that, can we now add like one of those? That's the thing with like things that are tilted. Those objects are always spawned with like an identity rotation. Now if I do it like number 2, yeah, now we can get one. Maybe we can get another one there without launching it into space. Number 2, yeah, there we go. Okay, that's good. But yeah, like I was saying, maybe we can dedicate a stream relatively soon to this level and making it AI drivable, AI navigable. It is still kind of slidey with a lot of stuff in the back. So that's going to be interesting to see how the AI actually manages to drive it. But I guess we may be able to like do something about that, make it less slidey. But it does seem like the NVIDIA, like the physics SDK, just sort of makes things a bit more slidey, or makes trucks specifically a bit more slidey if they have things in the back. So that's maybe something to look into. All right. Truck bed. Open up the hatch. And raise the bed. Bonk. And then of course you can drive away like this. Yeah, I kind of keep forgetting how ridiculously large these boxes are. The scale mannequin. They're like really, really huge. They look like they could be kind of small, but they're actually really, 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 really big. Yeah, okay, cool. After a little bit of math sort of unclarity there in the beginning, this went surprisingly smoothly, I might say. What if we fill this with like these small boxes? Those are the small boxes. Really small ones. We even have some spheres. If I was doing this in the editor, I could just duplicate them. But I can't do that here. Now we can get one of those. Doesn't matter. A bit more but smaller cargo. I think this is actually kind of closer to what we will have in the mission there. But it's not tested and implemented yet, so it might change. Woo! Things are sort of jumping around a little bit. Like that. Oh boy. Oh boy. And now, of course, we can do this. We can drive here. And I'm going to switch to this guy. And then... Or should I say gal? Blip. Lift it up with the cargo inside of the thing. There's just like an absolutely enormous amount of physics joints interacting here. It's kind of fun that physics is stable enough to just simulate this. Like even just the cable of the crane has probably like 10 or 15 joints here. Yeah, physics is great. Yeah, it's not without its issues, of course, but on the whole, it is pretty great. Bring it up. And then a bit forward, so we can drive a bit better. Lower this thing, lower it down, and detach. There we go. Okay, this is fun. I think we'll get some fun gameplay out of this vehicle still, especially when we get the gripper arm there in the front, which I need to start working on. I think pretty soon. There's some open questions there, like is that thing going to be sort of in the way when you are just driving around, so that you sort of stumble upon it almost, or how well is it going to work? But that remains to be tested. Anyway, I think I'm gonna end today's stream here. This was kind of unplanned, but I hope the stream was a bit more solid today, so that we can maybe use these settings in the future. Blip, blip, blip. Unload the cargo. Isn't that nice? Isn't that just nice? Yeah, now I have to like hold down the buttons like this to make it close. I'm gonna switch back and then I can drive away. So we definitely need like a reset function to that, but it's super simple actually to reset it. So just set those back to 0 over time, and that'll be that. Anyway, guys, thank you for hanging out today. And be on the lookout for more streams soon. If you'd like to play the game, be sure to check out the Discord and get the pre-alpha 1 version from there. And of course, be on the lookout for pre-alpha 2 pretty soon. And I think that about does it. Have a great rest of your weekend, and see you later.